Hello, everyone. Welcome to Azure AI Connect 2025. It is a very big event. I want to thank everyone for being here. There could be some mix-ups. I think we, we start with a little bit of a mix-up, but we have our speaker today with us right now. So I won't remove Justin from the presentation. I want to thank him for being here and also thank Nav for being the moderator. I'm just adding Justin to the stage. Hello, Justin. I'm going to unmute you. And Justin, you can unmute yourself and introduce yourself to us. Also, you can share your screen. Justin, are you there? Let's give a moment to Justin to. Uh, yes,
Huh?
we can see you. Hello and welcome.
Uh,
Hi.
Hi. I just came into this early. I'm scheduled at 11
Yes,
p.m. Yes.
I don't see the other speaker. So if you don't mind, you can start.
Okay, I'll need a few minutes to get set up
Absolutely.
in my
Absolutely.
room. Then that's fine. Yeah.
I will play the media, and when you are ready, just ping me in the private chat. I'm
Yeah.
removing
Sure.
you from the stage and ping me and I will add you. Okay?
Yeah. No problem.
Thank you.
Uh,
And yes, I think Justin is ready. Just give me a thumbs up, Justin, and I will add you to the stage.
Yeah, sure. We can get
Great,
started.
great. Thank you for joining.
Yeah.
This is an enormous event. I'm so glad that you joined because the speaker that was supposed to join is not here. So
That's
uh,
okay. I'm happy to
it's a
happy
good
to
mix.
give my
It's a good mix
presentation.
up. Thank you, Justin, for joining. I will not
Yeah.
take your time, so I will let you introduce yourself. One favor, please add your screen now so we can add it in the StreamYard.
All
Um,
right. Let me share my screen here. Um, I'm only on one monitor right now, so you might see a little bit of like you
no
know
problem.
of my notes and things like that. But I don't think it should be too much of a
No
problem.
problem. You can share also the window if you prefer.
Oh, it's okay. Yeah, well, because I might want to switch over to. Uh,
Perfect.
oh, it's okay. Yeah, it's no big deal. All right. So we got our
Perfect.
screen going there. So I'll probably, um, yeah, let's do. How can I share with notes here? Uh, all right. Let's go ahead and just share the whole.
It's before you. Oh, sorry.
Oh,
Before you go share a try screen, does it have? If you go stop sharing and share again, does it give you
All right.
options to?
I will
yeah.
now give you the stage.
If you go share
Hello to
again.
your partner there, and
I think
your
I'll just share like
Okay.
this. Yeah.
and you
Okay.
are set up now.
All right. Go ahead.
We cannot see your screen. You can just
Oh,
re-add it, please.
here again. How about there you go?
Yes, perfect. Thank you very much, Justin. The stage is
Yep.
yours.
All right. My name is Justin Pierce. I'm speaking to you today from here in Thailand. It's about 11 p.m., so a little bit tired. And this is my first time presenting live as opposed to like pre-recording or something. So we might make a few mistakes along the way. You'll just have to bear with me. Okay. Today I'll be talking about using semantic kernel specifically in .NET with Azure OpenAI. Um, this is kind of like an introductory level presentation. We'll get semantic kernel up and running in .NET, and then we'll kind of demonstrate how to chat with one of your models hosted with OpenAI. And we'll move on to talk about how to generate and store text embeddings. And finally, we'll kind of bring all of these things together and see how we can accomplish something useful, fun, or unique. Um, so this presentation is going to assume some light knowledge of C Sharp, since that's the language we'll be using. And I'm not going to dive into the nitty gritty science of how AI models work. I'll leave that to the experts there. There's probably better resources out there for learning how a sausage is made, so to speak. But I'm going to try to more tackle like what practical applications you can use AI for in .NET. Okay. All right. So what is semantic kernel? Semantic kernel is a library from Microsoft that supports C Sharp, Java, and Python. And it's essentially like some middleware that allows you to connect to all your different AI resources, like different AI models that may be hosted locally, could be hosted in the cloud, and it provides you with like a lot of tools to reduce kind of boilerplate code and build like scalable enterprise level software. Um, from what I can tell, the first pre-release came out in spring 2023, and I've used it over that time since then. And they do it's still kind of in beta, and Microsoft does tend to make a lot of breaking changes. So updating versions can be a little bit painful, but nonetheless, we're going to just go ahead and dive right in on how to get started with semantic kernel. So a few use cases. Actually, before we dive in, I'm going to go over a few use cases. AI is this super exciting and powerful, like emerging technology. But like I mentioned before, I like to tackle this from the perspective of like what kind of practical applications can we tackle using AI technology. After all, businesses are built on like solving problems, not just academic exercises. It can be really easy to get caught up in the tech and then fail to deliver like something useful. And that's where semantic kernel comes into play. I think it really helps bridge that gap between like a cool tech demo and a viable product. So after we get the basics down and we get towards the latter half of the presentation, I think you'll start to see what kind of real-world applications we can tackle using our AI models orchestrated through semantic kernel. Okay. So, as this is an Azure event, the first thing you're going to want to do is set up your Azure OpenAI resource in Azure. If you don't have an Azure account, you should probably go make one. And once you do, you're going to want to find this Azure OpenAI resource and create one. After you do that, you can navigate to the overview for your resource and click on the Develop tab. And that will list your API keys and your API endpoint, or in other words, the URL and the password in order to access your resource from the semantic kernel. Obviously, keep these things confidential. Don't put them into your code. Just kind of jot them down, or just keep the page open so we can use it. And also, for this project, we're going to be using semantic kernel version 1.17.1. Anybody familiar with .NET should be familiar with NuGet packages, the kind of the bread and butter of dependency management in .NET. In case for the beginners, in case you didn't know, you can just kind of right-click your solution and go to manage NuGet packages for solution in order to bring up like a search box that will allow you to install these packages. So yeah, these are the packages and the versions I'll be using. I believe there have been updates since then. And like I said, Microsoft sometimes does make some breaking changes. So the example code and the repo that I provide at the end of this session, if you don't use this exact version, you may need to make some adjustments. Okay. All right, so finally we can kind of get into some code here. The first thing you're going to want to do when you use semantic kernel is use the kernel builder, okay? Anyone who is familiar with ASP.NET might find the syntax somewhat familiar. You basically use this kernel builder to chain together a set of methods that will kind of set up your resources. So connect to the models that are hosted on Azure. And in this case, we're connecting to a chat completion model, what GPT-3.5, I think is what I have it configured as in my example, and then text embedding generation model, the default one that is in OpenAI. Again, you'll have to pass your endpoint and your API key, and also your deployment name for the model, which is arbitrary. But you'll need to pass all of these things to the kernel builder. And I suggest you use like .NET secrets or like application configuration files so that you don't have to hard code your stuff directly in your code. And lastly, the semantic kernel, the framework itself is modular. In other words, like the methods that you see available to you may be depending or depend upon what NuGet packages you have installed. So if you go, online and look at various tutorials and start kind of reading guides and stuff, and you see that they have methods available to them, especially if like methods regarding specific models or specific features. It may just be like an extension package that you need to download, like Hugging Face model extension package, or some of the memory related extension packages. So anyway, all right. So in addition to the kernel builder, we also have the memory builder. It's very much the same concept. It's just chaining together methods to configure the memory that you're going to use for your orchestration. For this example, for the sake of simplicity, I'm using volatile memory store, which essentially means that everything's just stored in RAM. And when you restart the application, you're going to lose any kind of history or anything like that. One that I've also used is the Chroma memory store, which is a database that you can run in Docker, and you just pass localhost to the Chroma memory store constructor, and then you'll have some persistence even if you close the application. There's some, I won't go over setting that up here. We'll just use the volatile memory store. And here we can go ahead and see what that looks like. So here we are getting our secrets. I wonder, can you see my, let me make sure you can see my, let's make sure you can see this. Oh, you cannot, I think. Let me share my screen to make sure that you can see the whole thing. Let's see. There we go. All right. Now you can see the whole screen. There we go. Thank you. Okay, so now you can see the whole screen, so I can kind of alt tab between my presentation and Visual Studio here. So yeah, we have our example code that I'll link to you at the end. Just getting some, whoops, that's the wrong example code. Yeah, so getting some secrets here. And here's the juicy part, building our kernel here. We want some text embeddings, for example, AI chat completion, and then later on we'll also do some AI text to image. Memory builder, like I mentioned, we're just using the in-memory store, and we also need some text embedding generation for this. We could use the Chroma memory store with 127.0.0.1, but that would require that I have Docker running with the database up. Okay. So after we set these up and call build, now we can use semantic kernel. So let's go ahead and dive into that, see what that looks like. Okay, so the first thing that probably most people will want to do with AI is set up your prompts. Okay, so defining a prompt and using semantic kernel is pretty easy. we're going to use the kernel.create function from prompt method, and we're going to pass it a string that is our prompt, and then also provide some execution settings that you probably are familiar with if you are familiar with AI, including things like the maximum number of tokens returned, the temperature, which is kind of like, I believe, like the randomness almost. However, semantic kernel has some unique aspects to it, to the prompt engineering. One of the biggest things is that you can include variable names using a dollar symbol in your prompt string. And then when you reuse that prompt, you can inject values into that variable. Okay, so let me see. Okay, yeah, so I'm going to talk a little bit more about the prompt engineering side of things. Basically, prompt engineering is like a whole. It's almost it's like an emerging field of study. You could almost say. It's almost like meta programming. I'm only going to dedicate a single slide to prompt engineering. But that said, I did want to kind of really briefly touch on how to make a good prompt, since that is going to be a big part of using the semantic kernel. So I'm borrowing a little bit from Mike Irving and James Montemagno's presentation that I saw linked on social media, and I really liked the kind of analogy or that they presented, which is to imagine your AI as an intern at your company. Most of you probably have worked with interns before, or have been an intern even, and little did you know that intern was preparing you for your future interactions with AI. So why an intern? Basically, you want to speak to your AI while avoiding any assumptions. So just assume that you don't really know anything about your context or the technical aspects of what you're inquiring about, or your intentions. Also, you want to break down your problems into kind of bite-sized pieces, so it's easier for the AI to kind of digest. And lastly, provide as much detail as possible in your prompt. So be very specific, be very detailed. Don't be afraid of being too wordy, so to speak. And you can, include various semantics in your prompt. For example, instruction, like translate the following code from Python to C#. You can ask it a question, what is artificial intelligence? And lastly, you can actually just leave an incomplete sentence and have it complete that sentence. Machine learning is a field of artificial intelligence and it will complete your sentence for you. There's a lot of good resources out there. I'll at the end of the presentation, I'll provide some links that can guide you further on prompt engineering. Okay. So assuming you've educated yourself on prompt engineering a little bit, let's just look at probably the most basic prompt that I could think of. And that is to summarize text. Okay, so in the gray text here, you're going to see the prompt, and we are going to use a variable so we can reuse this prompt. So we don't have to ask the AI every time we want a summary for a summary. Instead, we can use semantic kernel to kind of store this prompt, which you see here with this first chunk of code. And with this second chunk of code for invoking the prompt, we can put the text to be summarized, inject it into the variable, and then invoke the query. So this is kind of where you maybe start to see what semantic kernel is used for. It's used for reducing boilerplate code, for reusing prompts, for injecting variables, and it does that very well. For our example code, I have abstracted some of this into a class. Okay, so in this example, we have our execution of the prompt here, and we have our initialization in here. So we have a bunch of a bunch of prompts that we are initializing here, and yeah, let's go ahead and make sure it works. So I'm feeding it this text. Let's see, feeding it this text right here. Very, very simple text. I have some more sophisticated documents available as well, but I like to kind of just keep it simple for this. And you can see that. Wow, what a riveting summary. But nonetheless, it is doing its job. If you're more specific about your prompt, then you'll get more specific information. So let's go to a little bit more sophisticated and interesting kind of use of these prompts in semantic kernel. Okay, so first, as an aside, this is a great transition, but as an aside, let's talk about text embeddings, because we're about to use text embeddings in order to further expand our capabilities in semantic kernel. Providing a summary of text is useful, but what's even more useful is providing like your own data, say in the form of like PDF documents or just files and things like that, and then having AI be able to break that down and then tell you relationships that you wouldn't be able to devise by yourself. So that brings us once again back to text embeddings. Once again, I said I'm not going to go into the kind of academic aspect of AI. I'd rather focus on the practical applications. But very briefly, nonetheless, text embeddings are just kind of relationships between words or phrases represented by a set of numbers. So they give us a way to quantize language, words, and concepts. I find this concept super interesting, and I would love to kind of keep going on about it. But yeah, we'll just kind of keep it at that. Text embeddings are basically numerical representations of words, and you need a text embedding model in order to convert your words into the numbers. And since we are quantizing our language, that gives us a way to objectively compare words and concepts. So like this very simplified graph for demonstration purposes kind of helps you visualize that. Things that are coffee related are going to be clustered together, and therefore the distance or the objective similarity between words can be measured. So we'll kind of leave that concept there. That just know that you need a text embedding model in order to convert your data into a numerical representation of that data, and then we can use that to combine with a language model to kind of find relationships in that data, and then have the AI communicate those relationships back to you in a kind of human readable format. So how do we generate these text embeddings? In other words, how do we kind of feed our data to our model? Well, that's where the whole memory concept kind of comes into play. If you remember before, we set up the kernel using the kernel builder, but we also set up the memory aspect using the memory builder. So what is the memory aspect? That basically gives you the capability to take your data, kind of put it into chunks, feed it to your text embedding model, and have it be converted into something that the model can then use, that your AI can then use. Excuse me. So for as far as semantic kernel.net is concerned, we're going to use the iSemantic text memory save information async method. And here you can see it takes like a description, a collection, meaning like just an identifier that specifies what bucket to put into, some text. So this is going to be your actual data, and then an ID, like a unique ID. And this command will convert your text into text embeddings and then store it on the memory that you specified. In this case, we specified volatile memory. So once we restart the application, this information will be lost. Which is useful for prototyping and demonstration, but not too useful in the real world. You're going to want to set up some persistent memory, whether it be Azure blobs or if you're worried about your proprietary information or IP, you can set it up in a Docker container using something like Chroma. Okay. And very briefly, again, how you choose to store this data and break it down is going to have a large impact on your query results. Okay, so higher granularity is going to mean better accuracy. So, like if you just store one word as a unique object, each word as a unique object, then when you search for something similar to that word, you're going to get a more precise result. But if you pass, if you're parsing something like a academic paper or a white paper, you don't want to store each word as a individual object. Instead, you would want to store perhaps each page or each paragraph, or in some cases, like each new line. That way you retain the entire concept that is being conveyed within that sentence or paragraph or page as an object or as a embedding instance or whatever. So that's just something to keep in mind, and it really depends on like the nature of like what you're storing, the nature of the data, and all that. Okay, so in order to generate embeddings, we're going to use iSemantic text memory save information async to generate the embeddings and populate the memory. And then we're going to query those embeddings using iSemantic text memory search async. And I'll show you this in just a minute. And this step is important here. We're going to use a special prompt with our large language model to convert the embeddings back into something useful to us. So, for example, like if I let me find my input text. If I embed these two lines as text embeddings, and then I ask, what does Shelley sell down by, or what does Shelley sell? The text embedding result is going to be this entire sentence. Okay. So if I embed this line as a single instance and I ask, what color is Mary's lamb? If I only use the text embedding model, I'm going to get this entire sentence as a result. Okay, and that's not what you would kind of expect. You would probably want something more like what color is Mary's lamb? And the answer is blue, okay? And the way we can accomplish that is to combine our text embedding model with our large language model using a kind of clever prompt, okay? So let's go ahead and go and look and see what that looks like. Okay, so I believe I have a slide on this. I do. So, okay. All right, so here's the prompt. Here's the magic prompt. Chatbot can respond with facts or data pulled from user input, text embeddings, yada yada. It should only respond with those facts and say, I don't know, if it doesn't have the answer. And chatbot should keep the answer as short and concise as possible. And then here you're going to see a couple of variables. So you're going to see the embedding result that we're going to put into the prompt that we're going to give to our large language model. And we're also going to provide the confidence so that the LLM can make can kind of adjust the answer based on the confidence level. You could also alternatively provide, because text embeddings can return multiple results, like multiple matches essentially, and each of those matches will have different levels of confidence. So perhaps a more clever prompt here would be to provide an array of results to the large language model as well as their corresponding confidence. And then the model would be able to construct like a more sophisticated response. But in this example, we're just going to be returning the highest confidence result and using that. So let's go ahead and see what that looks like in our code. So I'm going to zoom out here a little bit. I don't know how easy this is going to be to be visible on the stream, but I just want to show that this is just the initialization method as outlined before. And we're going to go ahead and define our prompt and store it in an instance variable and do some other setup here. And in order to query, we are going to, I should need a little bit of more horizontal real estate here. Let's see. The main takeaway here is to use the search async to query for an embedding match, okay? Here I have it limited to only 3 matches, and it needs to be a relevant score of 0.4 or greater. Now, as I previously mentioned, this step only returns the match. So again, it's only going to return, if I separate this by new lines, it's going to return the entire line. If I just query blue and lamb, it will just return this entire line. So we want something a little more clever than that. So that's why we're going to take the result here and put it in our embeddings result variable. Okay, and here, let me go ahead and split the, let's see here, split the screen here. Oh, here it is. So I hope this is, let me pin this to the bottom. Okay, so embeddings result, we're setting it here. And then also the confidence level is being set here, okay? So now we have this predefined prompt that we've injected our embedding result from our query into the prompt. And now we're going to execute the prompt, and we're going to get a human readable result, okay? So start with something super simple. And let's go ahead and execute it. And yeah, I'm just gonna go ahead and hard code my query right into the code here. Okay, so what does Shelly sell? Let's go ahead and see and find out. All right, It says seashells. That is correct. Okay. So let's go ahead and let's have a yellow horse. So so I want to show, kind of demonstrate what I meant here. Let's go ahead and collapse this back up. And let's go ahead and look at our embeddings result for. So we're going to query, what color is John's guitar? Okay. Let's see what the embedding result for that is. So look at that. Text, because of the way that we stored the embeddings, this is the response we would get if we were only querying for embeddings matches. Because remember, it's just basically comparing numbers, okay? So we get this entire extra text for page 0. The document is everything that follows. Shelley shells seashells down by the seashore. John has a blue guitar and Bob has a yellow horse. We don't want all that. We just want to know what color John's guitar is. Well, and hopefully, once we pass that, there you go. We get blue. It's really beautiful how that all works out. Yeah, and like I said, you could, in this example, I'm just feeding the entire text file as a single embedding. But if you had sections, you might want to divide it up based on like headers in your PDF file or something of that nature, so that you can kind of logically divide your data. Okay. So hopefully you followed that. Yeah, here's the example that we just showed. And luckily that worked out. Okay, so that is a good example of how to combine text embeddings and your language model in order to kind of make the embeddings useful, query your data essentially. And I think I still have some time left here. I have a couple extra sections here, depending on how much time I have left. Yeah. So I have a little bit of time left, so I'm going to go over using Dolly, or basically text-to-image capabilities within Semantic kernel in .NET. Similarly to how we set up our chat model, we simply need to add an extra capability to the kernel builder. So in this case, we're going to call add Azure OpenAI text-to-image method. These method names are very verbose. And then we want to save a handle to the service. So in this case, we just call kernel.get required service, and we'll store that as a local instance variable. And this API will actually it doesn't return you image bytes or anything like that. It just gives you a URL. So here's some kind of boilerplate code to convert that URL into data. Yeah, we can go ahead and, this is very simple, run-of-the-mill text image generation, but let's go ahead and take a look at that. So here you can see we set up our text-to-image capability with the kernel builder, just like the other capabilities there. And then when initializing our kind of abstracted class, we also store a handle to the service right here. Okay. So let's go ahead and how about happy 40th birthday. I'm not 40, but it's just the first thing that popped in my head. Poster. And let's see what that looks like. So we'll go ahead and run this. And we'll get go ahead. Oh, I think we're using .NET 6. There we go. There you go. Happy 40th birthday. And it looks like we actually spelled everything correctly there. Yeah, look at that. It's very cute. Okay, so yeah, it's super simple to set this up. I guess the only caveat is you do need to enable these deployments in your OpenAI resource. Okay. And let's see. During my research for this presentation, I also kind of came across this this semantic planner, which I'm not going to go over in this presentation, but I did feel like it was worth a mention. Essentially, like modern AI models or frameworks allow AI models to actually invoke methods. So previously, like in order to invoke code, you would have to kind of serialize or serialize the schema for your methods as JSON. So essentially, and give that JSON to the AI. So essentially, you're telling the AI what your code looks like. Then request your AI to perform the method, and then it would respond, kind of telling you what methods to invoke. So you would have to kind of parse the response from the AI and invoke the code yourself. It was like it's like a very roundabout way of having AI invoke methods in your own code. But now there is a semantic planner, which actually allows you to register a plugin in the semantic kernel. In other words, you use the semantic kernel API to register a bit of code, and based on your prompts, the AI could execute that code. So, for example, you might have code that turns on a light bulb in your house, and you can say, turn on the lights, and it will execute that custom code that you've written to turn on your light, connect to whatever device or whatever it needs to do to turn on that light. I thought that was worth a cool new feature in the semantic kernel. And if you're kind of looking to be a more advanced user, it's definitely something worth looking into. Okay, so that pretty much brings me to my conclusion. Yeah, we covered how to connect your OpenAI model, your chat completion model, your text embedding, and even text image generation. I'll leave a link to like all the various reference documents, like the Microsoft documentation, as well as some other presentations that I got inspiration from, and most importantly, I'll leave a link to the example code. The repo is up on GitHub right now, that has all this code that I have, that I showed to you today. You'll need to, like I said, you'll need to set up your own instance of OpenAI in your own Azure account. But once you do that, you can get your example up and running. Yeah, and I hope you took something valuable away from this, and I highly encourage you to go out and try semantic kernel for yourself if you haven't already. That would be all. So, okay. That concludes my presentation. I'm I think I can hop into some comment section over here. Oh, excuse me. Yeah, and I'll join the chat. And looks like I gotta connect my YouTube account real quick. Hold on. Yeah, if there's any questions, feel free to ask. I will post that link now in the chat to the example repo here. Let's see. Let's see if I can remember how to use a computer. Okay. So here you go. So that will be right here. Oh, I think it's not going to allow me to post a link actually. There you go. Let's see if we can post this. Okay.
Justin, do you want me to share again your screen?
No, I just would like you to post the link to the GitHub that I put in the private chat.
Perfect. Will do.
Yeah. Excellent.
Here is the link from Justin, guys, in the common chat. So, any questions here for Justin? Any questions here, guys? You can post it in the comments. Yeah, I cannot see any questions. I want to thank you, Justin, for being here with us today. Excellent presentation. We have your contact. We have your GitHub right now for the recipe.
Yeah.
I hope we will see you again in another event. Have a great one.
Certainly. I look forward to seeing the other presentations as well. It looks like there's some interesting topics.
Yeah, we have a lot of them, and I'm really, I'm really thankful for everyone that submitted, including you.
Oh, thanks a lot.
Thank you
Appreciate
so much.
It, no problem.
So we're going to have about 5 minutes break, and we will continue with Bob. Many thanks to Justin. Bye bye, my friend.
All right.
See you soon.
Thank you.
All right. I'm just gonna play a little bit of a video, and then we will be back with Bob with a very interesting presentation. Just stay tuned, and we will be back. All right, we are back. Thank you everyone for joining Azure AI Connect 2025. Our next speaker is Bobur Uzbukov. Uh, the title of the presentation is Generative Feedback Loops in Action. I will add Bobur in the stage just to to understand what the session is about. Hello, my friend. I have to say I have known Bobur this year. We have an amazing collaboration in a variety of things and tasks. Thank you, Bobur, for joining.
Thank you for
Uh,
inviting.
can you tell us a little bit about what is this presentation about?
Yeah, of course, of course. Sorry about my voice because I'm just recovering from like a very weird flu. And then if you see like weird sounds of me, don't worry, like don't scare. I will try to my best to present this with better voice. Generative feedback loops, it's a pretty new topic. I would say it wasn't new, but now it's applying this approach more massively in AI technologies because as Gen AI or RAG approach was famous in AI use cases, we are looking ahead like what's next. Let's see. GFL is helps AI to improve its responses with the production data because production data always changes. There are always unexpected data. Then AI should be responsible always ready for production data context. So JFL helps to put this context in the
Amazing.
right time. I will try to explain this approach, how this JFL works, and at the end have a very nice demo of this JFL in action, how we can implement one by knowing these concepts during this session.
Perfect. You want to share your screen so I can add you on the stage? I can add
Oh, yeah,
your
sure.
screen on the stage.
Yes, let me share my screen in a moment. It's okay. Okay. Let me know if you can see my screen. It's
Yes, I'm adding it
loading.
right now in the stage.
Oh, okay. Okay. Now it's good.
And I have to say, your graphics are always amazing.
Thanks.
I'm,
I'm
I'm
using.
following you, and I can see
Yeah.
your presentations. Yeah.
Yeah. Thanks.
So,
Thanks.
what word is yours? Generative feedback looks generative AI. Um, Very interesting concept. I will shut up now, and Bob, the stage is yours.
Yeah. Thanks. Thanks, my friend. So yeah, as I already mentioned, GFLs or generative feedback loops are focused on more optimizing and improving your AI's outputs over time through the cycle of feedbacks. Feedback can be provided by the human, or feedback can be provided by the system you are using, or based on the production data. So this can be useful for, let's say, creating some personalized recommendations solutions or targeted ads. Whatever you see in some marketing websites, you will see always some suggested the products based on your preferences, right? And then also it helps you to create dynamic content and then makes a more powerful existing generative AI approach. So in this session, we will break down this how the GFL works. Let me introduce a bit shortly myself. My name is Babur, or you can call me Tiger, which is the English version. I'm a DevRel at Neon and also Microsoft's MVP for AI platform. I'm providing a lot of use cases, playing around with Azure AI services a lot. And that's why I would like to also present something cool like a GFL that's running on Azure today. Before understanding what a GFL is, we need to step back. Like first, review again, like revisit again what's a retrieval augmented generation, like RAG. First of all, maybe some of you already know, some of you maybe know not. So I can explain. Like RAG works basically by taking user questions and searching for information, relevant information to that question, and then including retrieve the information with your question, and then it sends this question and retrieve it data from your storage to AI chat model. Like you can say, ChatGPT, hey, or Cloudy, hey, DeepSeek, hey, please answer this question X using information I have A, B to C. ABC is coming from your storage. Or you can always see in the internet, or when you're discovering what's how the rack architecture, typical rack architecture looks like. It's something like this. We have some data as a corpus or input data. It's coming from different services, tools. It can be coming from Postgres or MySQL. It can come from some Slack data, Notion data, and PDF or docs. And you start to ingest this data because the data is actually always huge. You cannot fit into some text or into tokens, maybe, because number of tokens is always limited. That's why I need to have a pipeline, simple pipeline that takes this big data and divides into small chunks. All this data, we call this process, it's just pre-processing the data. Then once we have these small chunks, we calculate for each chunk a vector representation of these chunks. This process called also vector embeddings, correct? And the vector embeddings can be calculated using existing models from OpenAI, Gemini, LMI, or other models you can use to get a vector representation of your data. Why we are calculating the vector representation? Because it's easier to search for this data after we store this into vector databases. So we have big data, we chunk it, we calculate the vector, then we store this vector data into vector database. And you can use any existing vector databases like ViewWeight or Pinecone, or existing now Postgres solution also have a PG extension. You can store a vector representation easily. Then once the data inside a vector database, what do? You start to build your AI application. Let's build simple AI search tool that search something based on your data. It can search some tax information, or it can search some specific academic data based on your database. Now, in our case, what would you do? You start to build some front end and back end. And backend service always accepts some requests from UI, and the user asks questions. Show me the discounts happening this week in the Amazon market. Then what happens after? In the backend side, we calculate from the given question vector embeddings, right? To compare with the vector data we stored in the previous step. Because when you compare one vector to another vector, it's a higher chance you find a very similar data from the vector storage. Once you find the data similar for this question, you send another request to OpenAI, or using other frameworks like a LangChain, to chat completion endpoint, another famous endpoint, to say the AI, hey, give me now output based on the input I provided and based on the question. Then you will get a response quickly in the search bar as output. Yeah, I found a discount in Amazon. We have these shoes, we have these clothes, and so on. So how this is a simple Gen AI works. Now, once we understand how the Gen AI works, we can switch our focus to feedback loops. And Gen AI, as we understood, the primarily operates in one-way direction. It's generating content based on the input data we provided. And GFL, however, as you can see, incorporates a feedback loop where AI continuously learns and improves the outputs it generates itself. As it generates output, it sends back to the input again. And feedback loops originally designed when there were situations when AI generated content should be used to train new models. Like we are using GPT model, and we are providing some more data to GPT model using prompt engineering or Gen AI. But again, we want to improve the GPT and make it more customized for our use cases. This is how the GFL looks like from the high level. Let's deep dive from more in details. Like there are several feedback loop mechanisms exist in these years. Maybe some of them I'm not just taking on some approach based on my knowledge. Maybe there are more like feedback loops. There are feedback loops with training data sets. That's what we are using now, existing models, different type of models. And there are feedback loops driven by the human AI interactions. When the human says, yes, this is correct, and the AI says, yes, it accepts as its correct answer. And something new I'm adding in this session is feedback loops using vector stories. This is a topic we're going to cover, but I will also introduce feedback loops with training data set and human AI interactions shortly. Let's see how the feedback loops with training data sets works. This simple diagram, like as you can see, we have initially trained data, and we have a Gen AI model. We are adding some input data, as we added in the previous slides, and we are training that data. Also, we are always this input data is changing because it's not static; it's dynamic. Think about like also Airbnb or Booking.com properties data always changes. That's why we need to also update the Gen AI model with up-to-date information, and this also affects training data at the same time. This is how training data sets can affect on the Gen AI model itself. One of the examples, like from Microsoft provided products, like you can also explore Power Apps or Power Automate. It has a now preview feature called feedback loops inside the AI builder. I think if among you there are maybe users of Power platforms, you might know already. There's a very fancy feature called feedback loops. How it works, once you have existing well-trained models to capture data, to analyze the images or analyze the videos, audios. Also, you can retrain existing models provided by Microsoft with your production data. As you can see, there are existing models. Then you can also connect to the production data to discover more new models or customize your models. That's a simple, like a demo. I was playing around with Power Automation. I'm not going to dive into details, but there are already existing solutions that many SaaS products are already offering these feedback loops inside the Gen AI approach. What I did in this demo, I just uploaded some always changing documents. I'm sometimes receiving over email new PDF files on my Microsoft Outlook. Then the feedback loop should analyze and learn the context of these documents and retrain my existing model to understand better and better when time is ongoing. For example, there's a rental agreement document. One time I retrained the AI model, but next time if rental agreement changes, it is context slightly, AI model is ready always to accept these changes. This is something sort of you can set up already using Power Automate or Power Apps with the feedback loops feature. I'm going to skip this demo because it's not like our main topic. The next mechanism we said, like sometimes human can also lead the AI outputs. In this case, humans are directly influencing the output of your AI response. As you can see, we have training data, we have some PDF documents, and we are sending everything to Gen AI model. At the same time, we are considering or taking into consideration this human input. For example, think about this application, existing application for logistics. We implemented for BI agent for the funds company. As you can see, it's a simple like natural language to SQL conversion. and it fetches and creates some reports based on the human language, and under the hood runs some SQL queries. But here what we introduced is human based feedback. The same as ChatGPT has, like, if thumbs up, which means the AI response is good. If thumbs down, is AI response is bad. We did it also by accepting yes or no to analyze if AI response output is acceptable or not. As you can see, for the backend side, we have some ranking system, learning which SQLs has a higher correctness, or which SQL is not slightly not correct. We are just skipping them. Next time when we receive the same question or the same reporting, the input. So this is the example of how the human can influence the AI. So the third mechanism, which is most interesting one and something new, I would like to introduce you, feedback loops using vector storage. This diagram pretty much explains these steps. It's similar to Gen AI approach. As you can see, only differences in GFL, the results, as we said, generated from large language models like OpenAI, from OpenAI like GPTs, always vectorize it and index it and save it back to vector storage for better filtered and semantic search operations. And then, as you can see, this creates a very dynamic circle that adopts LLMs to newly changing data. Let's break it down. For example, in the first step, we have some input data. We are summarizing this data by asking chat completion endpoint, hey, we have like a long text, please summarize this. And then we are summarizing maybe from 10 sentences, we are making one sentence. And from the summarization, one sentence, we are sending to vector embeddings endpoint to calculate the vector representation of this one sentence. And we are storing this into vector database. Next time, whenever we get some input from the user, show me this one sentence, maybe user gives just one word in this sentence. And then it finds quickly the same sentence from the user input and shows output to the user. At the same time, it sends on number step 10 as input data to the system again. As you can see, we found a text matching, and we are mixing with production data and sending back to the same steps. We're summarizing, calculating vectors, and then storing again vector database. Why? So let me explain why. What are the benefits of this approach at all? Some of the advantages in these steps, as you can see, we are not only using existing GPT, also we're creating content. We are also making it adaptable to new data. If the data changes, vector storage always up to date. Vector storage always aware of things happening in the right time. For example, now if you ask ChatGPT about the current activities, it might not answer you correctly because it doesn't know what's happened today. It can know only based on the training data, maybe a week ago or a month ago. So in this case, it's always aware of these new changes. There is a combination of Gen AI, LLM model, plus GFL. So the repeated interactions between vector database and LLM, also it reduces initial bias and errors. If you get some bias or errors from the existing models, if you run multiple times the GFL loop, it reduces bias and slightly improves accuracy. Is one of the benefits of GFL here. Also, the powerful benefit is, I think, it provides more personalized outputs. For example, it knows what I want, like it knows what the customer's looking for quickly because customers' preference always change. I will show you a couple of examples in the upcoming slides. What are the real use cases of this GFL, and you will get this idea. And also, we're improving LLM knowledge over time. As you can see, we're building some user profiles that enables LLMs having a knowledge about the users. The best way to explain or bring example is of GFL in action is more personalized recommendations. Think about AI might suggest the products to the user based on their browsing history or number of clicks, purchases, and the user further interacts with this system, and recommendation provided by the feedback loops, always perfect. For example, in the real estate industry, let's say, all these property listings, rooms available, often updates like every day, maybe one furniture you add, or maybe availability of this property might change. Today is available, tomorrow is not available. If you're looking like for a hotel and using booking.com, and price changes, right? And then some futures changes. And then if you're using GFL, pipeline can automatically update this property description, let's say, based on attributes. If the price attribute or availability attribute changes, we can always change the description based on these attributes, and then we can offer to the users more compelling the suggestions when users are searching. Other use cases are is a very real world, like let's take a LinkedIn or Booking.com or Netflix. For example, on LinkedIn, real-time job listing optimizations might leverage GFL, of course. If you are continuously refining job postings based on the trends that candidates search and applications, for instance, AI can detect the search for this search. Then if someone looking for remote work or someone looking for only AI jobs, they can always see job listings based on their search. And it also increases its visibility, or it also increases attractiveness of the jobs. Or in booking.com, even some travel agencies might use a GFL to prepare some travel itineraries for the users by analyzing their feedback or preferences. AI can suggest some alternative destinations or accommodations, better match user interests. If I want to go to, let's say, San Francisco and search for some fancy places, it can recommend me based on my feelings or based on my interests. That's how things works. And the best example also, Netflix, when you are watching, you always see recommended the videos or video series dynamically changes. If you watch it like two videos in one genre, and the next day you will see similar like genres again for the recommendation. This is a real world use case of GFL. And another use case of GFL we would like to demo today, it's for podcast recommendation. The same way we can recommend the podcasts to the listeners using the GFLs. Without also GFL, we can achieve that, but we understand the power of GFL, that it makes a semantic search quite efficient. Also, we might have always real-time information. As you can see in this diagram, it's a very simple application I built using Python. There's also another version using .NET. It doesn't matter like which programming you use. If you understand the approach, you can implement using any framework or programming language. What we are exposing APIs, REST APIs, 3 different APIs. Like one is adding the podcast. Podcast has information like a transcript. We just assume that we converted from audio to transcript, then title of this podcast, and that's it. And we have what we are doing. We are first calculating vector embeddings from the podcast transcription, and we are storing inside the vector database or any database. In my case, I'm using just Neon, but you can use other database as well. At the same time, I am generating from the transcription summary, just a short summary, because usually podcast transcription, if it's running like half an hour, it's a quite long text. I'm just summarizing it and storing it again to vector storage for future use. And next API, we have like updating user history endpoint. What we are doing the same way. User always listening, maybe different like categories of podcast. Maybe today is listening about engineering, tomorrow listening about designing or other art stuff. Now we can also change using this API, user preferences or user podcast history. From the user podcast history, we are also calculating vector embeddings. Based on this information, we are storing again to the vector database. So, and the magic now is coming when you're using third endpoint, which is recommending podcast back to the user when user opens the web page or mobile application, and now they can see relevant podcasts in place. How that works? We are, as you can see, first retrieving the user listening history, yeah, as you can see, and we are from the because we had already embeddings of the user history, and we are sending over to another relevant podcasts. We're trying to find a relevant podcast based on the user history embeddings. Obviously, we'll have some matching. If there are podcast data set is big, we can always find the similarity. And we are, once we finding the relevant podcast based on user history, we are generating the, again, short summary using chat completion endpoint, and we are sending back to the user. As you can see, user history and podcast can change whenever they want. Like API can accept new changes every time, but the recommended podcast always gets today's information based on this architecture. So we are getting personalized podcast suggestions always in place. And from the deployment point of view, we are using Azure Functions. Like you can use maybe other type of services. I'm using Azure Functions. We have 3 functions that exposes APIs, and I'm using Azure OpenAI to use embeddings models and GPT 4.0 model. So, and the fancy part is here on the bottom. You might not notice in the same function, recommending podcast function, we are storing suggested podcasts. The same data we send to the user, we are storing back to the database. Why? In this case, when it will avoid duplications, like this data can be used to analyze past suggestions, what we suggested before, to avoid, of course, redundant recommendations. And also, it also gives us more analytics information in the future to measure the performance of our recommendations. For example, what was the average similarity score? What was the engagement rate? If the podcast listener liked this recommendation or not, and so on and so forth. We are keeping historical tracking of our suggested podcasts. This is very powerful. You can even make it more powerful by adding additional features on the top of existing solution. This is a typical, for example, input and output. Let's say user listening history looks like maybe user podcast listener about AI, deep learning, data science trends, and this is the output, what we can show to the user when we are providing suggestions, like AI revolution, data science today, all the relevant information, as you can see. So this is like how the application architecture looks like. Now we can jump on a short demo. I will show you how this works in action. Of course, we are not going to cover everything, like from let's say building blocks to the deployment to the Azure, but you can explore yourself by scanning this QR code. I have a GitHub repo example in place in Python. You can give a try. It's very simple to run and a simple application. So now I will go to my terminal and we can have some fun. Let me go to my terminal, then we can do some experiments. Yeah, I hope it's visible. Good. As you can see, maybe I can start better first to the GitHub repository. When you scan this QR code, it brings you to the generative feedback loop example, and you can also read some like description again, like to understand the GFL better. The same architecture diagram I put here, and some features I explained how the podcast system works in this case, and tech stack, obviously, and followed by how you can run the sample application by yourself. There's very simple also the data to create some database tables and so on. So let me go back to my VS Code. The functions I was talking about in the slides, here we have only, let's say, one function app.py file where we are creating 3 Azure functions. As you can see, I'm using Azure Functions library. For those who doesn't know Azure Functions, it creates a serverless execution environment. You don't have to manage your infrastructure, and just you can deploy this Azure function. It's ready to use. But we're gonna run now locally, and then maybe you can give a try to deploy to Azure yourself. The same Azure functions I have here, 3. One is we are adding the podcast, as you can see, updating user history, and recommending podcast. Let's go quickly one by one, like which each functions to understand each function responsibility. So the same way, like as you can see, we have some transcripts coming with title and podcast transcript. We are generating vector embeddings. We have another helpful method here. It's another, and inside another Python file called OpenAI client.py. We're calculating vector embeddings from the podcast transcription. Very easy. And the same way, there are another helpful method to generate the summary from the podcast transcription. That's it. We're generating embeddings, and we are saying to OpenAI, please summarize this podcast. And we are just summarizing. Once we have embedding and summarization, we're just putting into podcast episodes table. I will show you also where these tables are located now. So we're inserting into podcast table, and we are just responding to the user, yes, everything is okay, podcast added successfully. Very easy method. And second method, the same way, we are getting user ID. We have some existing users, and with their listening history in text. And we are generating the same way vector embeddings, and we are updating, as you can see, existing users table with their listening history information. User listening history information can be in separate table as well to make it more scalable. But in this case, very simple. Like we are just storing inside the users table, and then we are saying, hey, user history also updated successfully. Now it's ready to suggest some recommendations. And the recommendation podcast function, what we're doing once we have given a user ID by the mobile application or the private frontend, we're just selecting what was the user history of the podcast. We are getting the history embeddings, and then we are fetching similar podcast episodes based on the user history. Then we are returning back to the user. Meanwhile, we're returning to the user, we are inserting new data inside the suggested podcast table. As I explained before, like to better avoid duplications and future improvement of GFL use case. So that's it. This is the three functions, and we have some data in the database. I'm going to show you how it looks like the data now. I'm using the Neon serverless Postgres solution. It's like a 100% SQL. You can run it like locally, or you can use the cloud version. I'm using cloud version, which is on Azure, and I'm now on the Neon console. So as you can see, I have the three tables. Now they're empty, like podcast episodes, suggested podcasts, and I have some users table also here with some data, obviously. Some users we have, Diana and other Bob, and sorry, they have some listening history, and we need to calculate the vector embeddings. For our lives, also, I tested out, we calculate like a listening history, but we can add again like some new users and calculate listening history. So that's it. This is how the table looks like. If you're interested, you can also discover like the Neon yourself, like what it is. There are some fancy features it has for experimenting AI models. So now I'm switching back to my VS Code and try to run my applications. VS Code is great because it has a lot of good extensions to work with Azure functions. Like I really like it. For example, you can use shortcuts. Like if you press like F5, it runs your Azure function automatically, and it will be available on your local host. So let me show you here. As you can see, I'm debugging these three functions, and then they are up and running. Now I'm gonna send a couple of requests to these endpoints. So let's try. I have some curl commands, example curl commands in the same repo you can find to test it out. For example, let's try to add one more podcast because podcast table was empty. I'm going to add one podcast, sample podcast. I will send one request, and if everything's good, the podcast should be added successfully. Here are some like curl errors, but in reality, the podcast has been added successfully, as you can see. I can double check by switching back to the database. And then as you can see here, we added the podcast. Not only we added, we also calculate, it had an interaction with OpenAI. As you can see, it had this summary, and this original transcription, summary and embedding were generated already by the OpenAI. So, which means everything's correct, it's working. Now I can try to update user history. User history, the same from the slides, like user interested in robotics and AI. I can run this query again, and then user listening history is updated as well. If you go and back to the database and check, here users table has updated the podcast information. You can try also with other users, it doesn't matter. You can try to increase also volume of your data, or maybe connect to more real-time podcast data. It should work fast enough in this case. And the last step is, let's give a try to fetch recommended podcasts. I'm going to run recommended podcast for the user with ID 1, and here we go. As you can see, I am getting one podcast suggestion because the user was interested in robotics and AI, and here we have one podcast found, and we have a similarity score also was high. So this is how the magic of the GFL works. In this scenario, you might not like if you get the benefit, direct benefit, but now if you connect to and deploy it into the production, now you will have always relevant information for the user. So this is something I want to show to you. Others like very simple, the project helpful like the Python scripts for connecting database, OpenAI client. You can give a try and try to simulate again this GFL use case. So now I'm switching back to my presentation to summarize some of the points. So yeah, and we have also, I'm playing around with a lot of AI use cases, and there are some other cool Neon plus Azure Rack demos. You can also try them out, which is running on Azure everything. Then I think that's it from my side, all the part of the presentation I want to show. Now, if you have any questions, we can maybe discuss now. You can leave in the chat. I will be more than happy to address them. Thank you.
Wow. Thank you so much, Bobur. What an interesting session. Of course, I will be watching it again. I don't know if our audience has any questions for Bobur. Yeah, I believe that this type of presentation sets the stage for what's coming next in AI, right? We are improving AI systems and generative, these feedback loops are meant to improve the whole process.
Yeah.
Thank you so much. I don't know if we have something. No, I cannot see any questions
Are
here.
we? Yeah, are we on time? Because I was looking on the slides, but
Yeah,
I think we're on
absolutely.
time.
Yeah, we are on time. We are on time. So, Bobur, we will stay in touch, right?
Of course.
Yes, and I would like to thank you for being here with us today. I hope we will see you in another event of ours. And of course, we stay connected and exchange ideas and,
Sure,
remain
sure.
connected.
I'm always ready. Whenever you invite me, I will come and speak. I have
Yeah,
other interesting topics. I can bring them out, especially like AI agents topics are becoming like a lot of famous. I
yeah,
have a couple of topics also in AI agents.
yeah, yeah. We will plan something, and we are planning also Global Azure in Athens, Greece. I know that it could be hard for you to come here in Athens, but we may also plan a virtual session for Global Azure. We will see. We will see.
Cool.
Again,
Oh,
thank you, Bobur, so much. Bye,
thank you.
and
Thank you.
and
Take care.
stay healthy, man. Stay
Thank you so
healthy.
much. Yeah, thank you. Take care.
Bye bye. Bye
Ciao.
bye. Yeah, and I think it's that's it for today. I cannot see our next speaker. I don't know if Lee